Hi everyone, let's take a look at the following example. Find the integration or the antiderivative of 4 times x squared times e to the power of x to the power of 3 with respect to x. Step number 1, when you think about the constant 4, you can bring this to the front. So you can rewrite this as 4 times the antiderivative of x squared times e to the power of x to the power of 3 with respect to x. Step number 2, let me switch colors for you. You can go back and again use this method called the method of substitution. And what that really means is, in this case, you have to let u be the difficult part such that the derivative is a scalar multiple of the other part. In this example, u equals to x to the power of 3. And the reason is because when you find a derivative, du by dx, meaning you want to differentiate u with respect to x, this would give exactly 3 times x to the power of 2. And if you look at this, you can isolate 4 x to the power of 2, or x squared, times dx. So notice I'm cross multiplying here. And on the left hand side, this becomes du divided by 3. Again, let's show you exactly what I see. Again, I hope we're looking at the same thing. X squared dx is exactly du divided by 3. And if you look at x to the power 3, that's going to be right there, x to the power 3. So this signals to you, we can go back to the original. We write this as 4 times the antiderivative of, instead of writing x squared dx, it's going to be du divided by 3. And instead of writing, let's try this again, 3. And instead of writing e to the power of x cubed, it's going to be e to the power of u. Now, you know this now because we've done a bunch of examples prior to this video. You can always go back and watch the other ones. Now, we can go back and find the antiderivative. Now, I'm going to show one more step just in case one person is not connecting. Nobody should be left behind. I'm bringing the 1 over 3 to the front. So this is going to be 4 over 3 times the integration of e to the power of u with respect to u. And again, here's the next step. I'm going to put it here. Now, when you find the antiderivative of e to the power of u, it is still going to be e to the power of u. Don't forget, you have to add a constant, c. You're not looking for one solution. You're looking for infinite many cases. If you go back and you plug it back in, this is going to be 4 divided by 3 times e to the power of x to the power of 3 plus constant c. Now again, how do we know we're doing this right? I would say to everybody who's watching this video, you spend 1 extra minute and you double check. To double check, you have to find the derivative of 4 over 3 times e to the power of x cubed plus c. And if you do it correctly, you should get exactly the question back. So again, I'll do this with you through a dialogue, and you can write this down on paper, of course. When you find the derivative of e to the power of x cubed, that's going to be e to the power of x cubed times the derivative of x cubed, which is 3x squared. The 3 at the top and the bottom can cross out, and this will give you exactly the question back. Of course, when you find the derivative of a constant, that's going to be 0. So again, by double checking, you can get 100% every single time, all the time. I hope this makes sense.